So good morning all. Today it is our next lecture of basic electrical and electronics. So today we are just taking a recap of previous lectures what we have covered. So we are taking the second unit, that is your fundamentals of diodes. So in fundamentals of diode, we first of all saw what is meant by diode. It has two terminals, anode and cathode. So now anode is your positive terminal, that is p-type region, and cathode is your negative terminal, that is your n-type region. So let me share the screen so that you can see the construction details of diode. So as you can see here, the on screen, this is the n region which are having the negative electrons. This is the p region which is having the positive holes, correct? So that's why it is called as a p region. P region means the trivalent impurity, and the n region means the pentavalent impurity, correct? So here, as you can see, this n region, p region is separated by this p-n junction, correct? And on both sides of this p-n junction, we are having the depletion region. So what is depletion region? The region which is separating the p region and n region, correct? So here, these electrons and holes are there. So this is the basic construction of p-n junction diode. Getting? And this is the barrier potential. As you can see, electrons cannot cross this junction and cannot go to p side, correct? So this is called as a barrier potential. Getting? And for the silicon, this barrier potential is around 0.6 volt, correct? And for germanium, it is 0.2 volt. This barrier potential. Getting? So when we connect diode in forward bias condition, and when we apply this much amount of voltages, then diode starts conducting. Hopefully the topic is covered now, correct? Any doubt in this? Then we saw the rectifier. Now what is meant by rectifier? Rectifier is a device, or you can say a circuit, which is used to convert the AC signal into the DC signal, or DC. In terms, you can say the pulsating DC, because rectifier converts it into pulsating DC. That DC is not a pure DC. It is not pure DC. That's why it is called as a pulsating DC. Correct? So there are major three types of rectifier depending upon the output and the construction diagram. The first rectifier is called as the half-wave rectifier. Half-wave rectifier means out of the full wave, AC has full wave, that is positive half cycle, negative half cycle. AC has positive half cycle as well as negative half cycle. As you can see, I can draw like this. Like this. This is the positive, negative wave. Getting it? So this is positive half cycle. This is positive half cycle. This is the negative half cycle. This is AC wave, correct? This is AC input, correct? And at the output, you generally get this DC. You get signal like this. This is DC output, correct? So AC is converted into pulsating DC. It is not pure DC, but pure DC is nothing but the flat signal like this, flat DC voltage. Getting? So this is not pure. That's why it is called as a pulsating DC. Now, if only single half cycle is rectified, then it is called as a half wave rectifier. And if full cycle means positive half cycle as well as negative half cycle, when both the half cycles are rectified, then it is called as a full wave rectifier. So in full wave rectifier, again depending upon construction, there are two types. The first type is when suppose you are using two diodes for converting the AC into pulsating DC, that is called as a center tap rectifier. And when you are using four diodes, means four diodes are arranged in the bridge configuration, then that type of rectifier is called as a full bridge rectifier. Hopefully you are getting it. So three types of rectifiers are there: half wave rectifier, center tap full wave rectifier, bridge full wave type rectifier. So we'll see the circuit one by one. So the first type is your half wave rectifier. So here, as you can see this diagram. So as you can see here in this new sharing diagram, this is the circuit of half wave rectifier, correct? As you can see, only one diode is there, correct? Only one single diode is there. This is the transformer, correct? Here we are applying the AC input. As you can see, this is the AC input, correct? This is what? AC input. Okay. So AC input is there, correct? And the DC pulsating output is there. Means it is not pure, it is not perfect horizontal line, correct? So it is pulsating. For positive half cycle, you are getting positive half cycle at the output. For negative half cycle of input, you are getting zero output, correct? As you can see here in negative half cycle, it is showing the negative, that is zero. Okay, so it is pulsating DC. Getting? So this circuit is half wave rectifier. So in positive half cycle of input, we have already explained that this positive is towards p-type material, this negative is towards n-type material. You can check my previous videos also that I explained the half wave rectifier. In that half wave rectifier, in positive half cycle of the input, this diode is forward bias. So obviously diode is forward bias means it is conductive. Okay, so it can carry the current. So current is going towards the output side. So in positive half cycle of input, we are getting the positive half cycle of output. In negative half cycle of input, this diode is reverse bias. This diode is reverse bias, correct? So in reverse bias condition, we know that width of depletion region is enlarging. So obviously no current is flowing in that widening of depletion region condition. So in half wave rectifier, in negative half cycle, current flow is zero. So obviously output is also zero. So here output is zero for negative half cycle. So this is the condition for the half wave rectifier circuit diagram. So you are having around 2 or 5 minutes. You can recall this circuit and you can ask whatever question you want to ask in chat box. So chat box is open. You can ask the question. Okay. So again, see that circuit, see the input output configuration, and then you can recall the answers. Okay. So we are having the 2 to 5 minute time. So check this circuit again and ask the questions. Okay, so I'm muting myself now. Is there any doubt? If you are not having any doubt, you can post in chat box if you are not having any doubt. Yes or no? Okay, Rushi Sonone. Wait a minute.
हा सर, बोथ हाफ वेव्ह रेक्टिफायर नाव लिहिले, त्याच्यावरती बोथ साइडला दोन डायग्राम सारखं दिसते बघा, लाईन सारखं, ते काय आहे?
ओके, आता ते सांगतो मी. हे बघा, हे जे काही इथं मी सर्कल करतोय, करेक्ट, याला जे मी सर्कल केलं, ओके, इट इज कॉल्ड एज अ ट्रान्सफॉर्मर. इट इज कॉल्ड एज अ
नाही सर,
ट्रान्सफॉर्मर.
त्याच्या खाली बघा ना.
कुठे?
तेच ते दोन्ही.
अच्छा, इट इज कॉल्ड एज अ ग्राउंड. जनरली जसं आपण आपल्या घरामध्ये अर्थिंग कनेक्ट करतो ना, अर्थिंग कनेक्ट करतो ना, अर्थिंग. सो इट इज सेम लाईक दॅट, ग्राउंड. ऋषी, क्लिअर आहे डाऊट? ऋषी, डाऊट क्लिअर आहे?
हो सर, क्लिअर झाला.
ओके, कोणाला दुसऱ्याला डाऊट आहे काही? Hopefully it is clear now. Now I am sharing the full wave bridge, sorry, center tap rectifier. If you see different books, then there are different types of diagrams for center tap rectifier. So it depends upon you actually. Hopefully you are getting the diagram. So In previous lecture, in the lecture of center type bridge rectifier, if you go through my video, you will find different circuit. But this circuit is the same circuit what we have shared there. Only the difference is there the resistor was connected here vertically. Okay, only this is the difference, but working is same. So in positive half cycle, diode D1 is forward bias, diode D2 is reverse. So in positive half cycle of input, current is going to the output through this diode. Hence you are getting positive output. And in negative half cycle of input, this D2 is forward, D1 is reverse. So current is going through D2 towards the resistor. But as you can see in both the case, here the current is in same direction. Correct? Na? So that's why the second current is also positive current. So in positive half cycle D1 is forward, in negative half cycle D2 is forward. Hence current is same. Getting? Hope you are getting it. Now again you are having few minutes so that you can ask me the questions. Anybody, if you want to ask the question, you can post in chat box, or otherwise you can raise your hand. Okay. So Darshan. Darshan.
तर ते राऊंड केलं ते फर्स्ट टाइम ते काय
Hello.
फर्स्ट टाइम जो राऊंड केलं ते काय आवाज येतोय सर हॅलो
Hello. हाँ.
सर आवाज येतोय का
हो.
सर ते फर्स्ट टाइम तुम्ही राऊंड केलं ते काय
कुठे?
फर्स्ट टाइम जे तुम्ही राऊंड केलं होतं ना ऋषिकेशने विचारलं त्याच्या अगोदर
त्याला ट्रान्सफॉर्मर म्हणतात. ट्रान्सफॉर्मर.
ओके ओके.
तुला आपल्याला ते इलेक्ट्रिकलच्या युनिट्स मध्ये शिकायला मिळेल परत लास्ट युनिट मध्ये. म्हणजे इलेक्ट्रिकलचे 3 युनिट्स आहेत त्याच्या लास्ट युनिट मध्ये शिकायला मिळेल. ओके. सेम इथे जे आहे मी त्याला आता सर्कल करतोय, that is the same, that is transformer. Transformer converts high voltage into low voltage. Okay. कोणाला अजून काही डाउट्स आहे? कोणाला काही डाउट आहे अजून? Okay, so we'll move on to the next point, that is bridge rectifier. Okay, actually we are having only 5 to 6 minutes now. So see the circuit. As you can see in this circuit, 4 diodes are there: D1, D2, D3 and D4. Okay, so here in case of positive half cycle, means when plus is here, okay, plus is here, minus is here, in that case D1 and D3 both are conductive. So current will follow the path from D1, then through resistor, then through D3 and then towards negative terminal. Correct? So current is following this path. Correct? The arrow I have drawn. So here in that case, current is going in this direction. And in case of negative half cycle of input, I am using the red line. See, current will follow here now D4 and D2. Both will be forward bias, and D3, D1 will be reverse bias. So obviously this current will go then through D4. Okay, sorry. This current will go through then D2 first, then through the resistor and then through the D4 towards this negative terminal. So in both cases, the current direction is again same as your previous center tap rectifier. Okay, so in both the cases, current is following this path. Okay, so current is positive, hence you are getting output like this in positive half cycle and in negative half cycle. Getting? So in both cases, the output is positive. Okay, for this input, see, I am drawing input here. This is your input. So in positive half cycle, you are getting this positive output as it is. In negative half cycle, you are getting negative output as it is. Okay. Again, is anyone having doubt? You can ask the question. Huh? I'm ready to unmute you, or you can ask the question in chat box also. Okay, now I'm audible. So here in this case, in half-wave rectifier, only one diode is there. So in positive half cycle, that will be on. In negative half cycle, that will be off. So obviously output is getting half of input. Hence it is called as a half-wave rectifier. Then in full wave bridge rectifier, we are having 4 diodes. Okay, so 4 diodes are there. D1, D3 are on in positive half cycle. D4 and D2 will be on in negative half cycle. So obviously D1, D3 will generate output for positive half cycle. D2 and D4 will generate output for negative half cycle. So this is the case for bridge rectifier. And in center tap rectifier, the case is we are having 2 diodes only. So for positive half cycle, D1 is on, and for negative half cycle, D2 is on. So alternatively, you can say vice versa. One is on, another is off. So here in bridge, we are having 4 diodes. So obviously 2 will be on in positive half cycle, 2 will be on in negative half cycle. So that is the case. So it is very simple to understand and simple to keep in mind. Okay. So I hope now you are clear.